T10.13. Researchers wondered whether maintaining a patient's body temperature close to normal by warming the patient during surgery would affect rates of infection of wounds. Patients were assigned at random to two groups. The normothermic group, core temperatures were maintained at near normal, which is 36.5 degrees Celsius using heating blankets, and the hypothermic group, where the core temperatures were allowed to decrease to about 34.5 degrees Celsius. If keeping patients warm during surgery alters the chance of infection, patients in the two groups should show a difference in the average length of their hospital stays. Here are summary statistics on hospital stay, measured in number of days, for the two groups. Okay, so normothermic, that's going to be group number 1, just because it's the first row. Hypothermic will be group number 2. Okay. Part A, construct and interpret a 95% confidence interval for the difference in the true mean length of hospital stay for normothermic and hypothermic patients like these. Okay. All right, so that's going to require the 4C method. So choose. All right, so the procedure is a 2-sample T interval for mu1 minus mu2, right? We're talking about the difference in the true means. So that's what mu1 minus mu2 represents. All right, our parameter, mu1 minus mu2, is exactly that. It's the difference in the true mean length of hospital stay okay, and the order of the difference, it's the normothermic group minus the hypothermic group. Okay. All right, confidence level is 95%. All right, now we'll check our conditions. So there was no random sampling. Let's make sure we're clear on that. You can read through the question stem again, and never once does it say random sampling or samples. It does say patients were assigned at random, so random assignment. That's fine, right? It still meets the random condition. Okay, so I'm just going to quote that phrase, assigned at random. Check. All right, now here, because we have random assignment and not random sampling, the 10% rule does not apply. Okay, the 10% rule only applies when you are sampling without replacement, which we're not doing in this study. All right, last, you look at the sample sizes or the group sizes. We have 104 in the first treatment group, that's at least 30, and 96 in the other group, which is also at least 30. So our final condition, which is called the normal/large sample condition, is met by the central limit theorem. All right, so now we can move on to the calculations. Okay, point estimate plus or minus margin of error, right? That's the structure of all confidence intervals. The specific formula here, because it's the 2-sample case, we'll have x bar 1 minus x bar 2. You know, that's what I'm missing in my choose step, right? I normally would write the statistic there. Okay, all right, no worries, we'll figure it out now. Okay, x bar 1 minus x bar 2 plus or minus a critical value that comes from the t-distribution times the standard error, which is the square root of s1 squared over n1 plus s2 squared over n2. All right, so we're going to have a 12.1 minus 14.7 as our point estimate, plus or minus. Okay, now we have two groups, so there's two potential degrees of freedoms. We could have degrees of freedom 103, or we could have degrees of freedom 95. Okay, the rule of thumb, if you're doing this conservative approach, is to use the smaller degrees of freedom, 95. Okay, so let's erase all this. Okay, so I think our confidence level was 95%. Our degrees of freedom is 95, but that's not it. That's not it either. We have to round all the way down to 80. Okay, so our critical value is 1.99. 1.99 times the square root of 4.4 squared over 104 plus 6.5 squared over 96. All right, so that was me plugging in the numbers. Now I'm just going to go to my calculator, type that in, get the endpoints of our interval. 12.1 minus 14.7 minus 199 square root 4.4 squared over 104 plus 6.5 squared over 96. All right, so the left point of the interval is negative 14.17. And the right endpoint of the interval is negative 11.03. All right, and now our conclusion. We are 95% confident that the interval from negative 14.17 days to negative 11.03 days captures the true difference in mean length of hospital stay. And that was the normothermic group minus the hypothermic group. Yeah. Now, because all the values in the interval are negative, that would imply that the normothermic group has a shorter mean hospital stay than the hypothermic group, right? This means, because it's negative, that the first group has a lower mean than the second group. Okay, so the normothermic patients have a lower average hospital stay than the hypothermic patients. Okay. I think that's what Part B is going to ask. Does your interval suggest that keeping patients warm during surgery affects average length of their hospital stay? I would say yes. Because the interval is completely negative values, it means the normothermic, group 1, basically the normothermic group, has a lower mean hospital stay than the second group, which is the hypothermic group. Okay, now, bear with me, if the interval had been all positive numbers, that would mean that the normothermic group had a higher mean hospital stay than the hypothermic group. If the interval had been both negative and positive values, then 0 would be in the interval, and that would mean that there really isn't any difference, any evidence of a difference. It's possible that there's no difference between the groups.